This is a metal spring. Its oscillation frequency is 1 Hz. If we apply an external force at 1 Hz, its oscillation matches. That means when the force frequency equals the spring's natural frequency, the vibration is largest. We call this phenomenon resonance. In electronics, there is a similar resonance. For example, in this series RLC circuit, there is a frequency that makes current maximum, also called resonance. So what is this frequency? Like the spring, resonance happens only when the force frequency matches its natural frequency. In the circuit, when AC frequency equals its natural frequency, resonance occurs and current is maximum. A spring's natural frequency is easy to see with our eyes. But how to understand a circuit's natural frequency? It's simple. Look at this circuit with a charged capacitor. If the switch closes, the capacitor discharges quickly, energy mostly lost in the resistor. The discharge curve looks like this. But if we replace the resistor with an inductor and capacitor both store energy, not consume it. Then closing the switch, the capacitor discharges into the inductor's magnetic energy. The capacitor voltage drops like this, approaching 0. Next, the inductor charges the capacitor in reverse. The capacitor is fully charged in reverse. Waveform looks like this. Since reversed capacitor voltage is negative, then the capacitor discharges in reverse into the inductor. Here is the discharge waveform. When voltage reaches 0 volt, discharge ends. Next, the inductor releases energy back to the capacitor. The capacitor is charged again. The waveform looks like this. That completes one charge-discharge cycle. The waveform is close to a sine wave. Without losses, it would oscillate forever. But with resistance, energy is lost, so amplitude decreases. The oscillation frequency is the circuit's natural frequency. Its frequency is 1 to LC. So it depends only on L and C. Back to the circuit, applying a sine signal at its natural frequency causes resonance. At this point, current is maximum by Ohm's law. When current is max, total impedance is minimum. Resistance, capacitive reactance, and inductive reactance are in ohms. Inductor has inductive reactance, capacitor has capacitive reactance. This is the impedance formula. When inductive reactance plus capacitive reactance equals 0, impedance is minimum. The frequency from this equation is the resonance frequency. Here impedance is lowest, L and C cancel, so current is largest. This is the resonance curve. At resonance, impedance equals only the resistor. At near 0 Hz, impedance is infinite. Because at DC, capacitor blocks current, so impedance is infinite. At infinite frequency, inductor blocks current, impedance is also infinite. In summary, at resonance, L and C fully exchange energy, electric and magnetic. At this point, the circuit is purely resistive. This is my simple understanding of series resonance. Hope it helps you.